This lecture concerns graphing tangent, cotangent, cosecant, and secant. And what we can do to get these basic functions is, again, we can start with a unit circle, and then this would be how you'd get sine, for instance, is we plot around, we move around the unit circle, sine is a y value, you can see it tracing out, cosine's an x value, that traces out. Tangent you can think of as the slope of, so it's sine divided by cosine, or the slope of that black line. So this would be tangent. And you see there's asymptotes at the bottom and the top of the circle where it's undefined. You can also say then cotangent's the inverse of that. So cotangent is now instead of opposite over adjacent, it's adjacent over opposite for these right triangles in here. So here's cotangent. It's like tangent but flipped over and moved to the side a little bit. Cosecant and secant. There's cosecant, and it relates to sine in that they're reciprocals of each other. Here's secant, and it relates to cosine in that they're reciprocals of each other. And here's everything all together. And so we'll parse that a little bit and look at them individually so it's not quite as confusing. Okay, back over to here. Actually, let's go into the textbook next. So our basic tangent function then looks like this. This is one period of tangent. It repeats every pi, so the period is not 2 pi. The period is only pi. Goes through at the origin, asymptotes at pi over 2, negative pi over 2, and then adding multiples of pi after that. As far as amplitude for tangent, cotangent, you can't really have an amplitude because they go up and down to infinity, negative infinity. But the idea is that you know that pi over 4 is going to correspond with the height of 1, so that's something we can use later on. Cotangent is going to look about the same, but just reflected over a bit. So here's the cotangent function. It has an asymptote at the y-axis, and then it multiples of pi. Again, the period is pi for cotangent. It's flipped over compared to cotangent or tangent and moved to the side. And then looking at secant and cosecant, the way we imagine those is based upon sine and cosine. So if you have your sine curve here in gray, wherever that is 0, wherever it hits the x-axis, will be asymptotes for cosecant because you can't divide by 0. And 1 divided by 1 is 1, so you can see that they match up at 1. And as sine goes smaller, cosecant goes bigger. And so we have these U shapes. And then the same thing with the way cosine relates to secant. Asymptotes for secant when cosine is 0. And then as cosine drops, secant rises, and you get these same characteristic shapes. These have periods of 2 pi, whereas, again, tangent, cotangent, only periods of pi. So now looking at some examples. This particular one here, cotangent of x over 2. Okay, well, we can first of all rewrite this as cotangent of half x. So let's draw in some basic cotangent values. And so we know that there are asymptotes over here, and let's put another asymptote, say, over here. I'll put another asymptote back over here, and cotangent's going to come down like this, about like that. So normally this would be over at pi, but we take our period pi, our period of cotangent, and divide it by 1/2, and we end up getting 2 pi. So everything is stretched out to 2 pi. So that means this will be at 2 pi. This is going to be at pi. This will be negative pi, negative 2 pi. And then over here at pi over 2, that should match up with a height of 1. So that takes care of our cotangent by drawing in these curves, and then takes care of the half when we change the period of everything. This one is significantly more complicated, this one coming up. So this will illustrate a lot of different things. 1/3 secant of pi over 2 times x plus 1. If you see a situation where this is multiplied out, pi over 2x plus pi over 2, just factor out so you can get the b value all by itself. So first of all, I'm going to draw cosine because cosine and the secant are reciprocals. So first, here is cosine. Now what I will do is incorporate in the 1/3. So this is a 1/3. This is a negative 1/3. I am using a method that I illustrated in the lecture graphing sine and cosine. So if you're not familiar with what I'm doing as far as first placing the graph and then adjusting axes and labels afterwards, you should go back and look at that lecture. So again, the lecture of graphing sine and cosine explains the general method. So I've taken care of the 1/3. Now I'll take care of the pi over 2, which will affect the period. 2 pi divided by pi over 2 is equal to 4. So this is 4. This would be 3, 2, and 1. So that takes care of this. Now this plus 1, that moves the graph to the left, but alternatively, I can move the y-axis to the right one. Think of this as x minus negative 1. So this being an x minus negative 1, again, I move the graph to the left one, but instead of moving the graph to the left one, I'll move the y-axis to the right. So then my new y-axis is going to be over here. And what that will do then is it will make, it'll change all of my axis values for my x-axis. So this becomes a negative 1, this is 0, this becomes 1, 2, and this becomes a 3. I have asymptotes at this line over here. I also am going to have an asymptote over here, because remember the idea is to be graphing secant. So these are asymptotes. Okay, so I've taken care of the plus 1. And finally, I want to graph in what secant will look like. And so in order to do that, I have to draw in the appropriate U shape, so to speak. So I've got one coming up here, and then piece is going to come down here, down like that, and then one up over here. So this would be one period of secant. So there you go, there's the whole graph. So now just to show you a couple more completed examples. To do this one, this is 1/2 tan 4 pi x. So in order to do this one, what I first did was I graphed 2 periods of tangent. That's what you see in blue here. That was my tangent. I know the period is 4 pi, so the natural period pi divided by 4 pi gives me a period of a fourth. And so from this spot to this spot is 1 period, so I made this a fourth. So therefore this asymptote's halfway, so it's at an eighth. There would be the next asymptote at 3/8. There's one at negative 1/8. And then to get this sort of pseudo-amplitude correct, halfway between this intercept and the asymptote would be where you want to correspond to this height of a half. And then one more example. Here's 3 cosecant of x minus pi over 2. And so first thing I did was I graphed in a sine curve. And so here was my sine curve over here. I extended it back a half a period to the left, as you can see, but here's 1 period of it. And then to put in this amplitude, I made these heights 3. So you see the 3 and the negative 3, which referred to the top and bottom of my sine curve. The curve has moved pi over 2 to the right, but instead I moved it, that y-axis pi over 2 to the left. So my new y-axis went from the black to the blue. This became, I add pi over 2 to everything, so this becomes pi over 2. Pi over 2 and pi over 2 is pi, so then 3 pi over 2, 2 pi, 5 pi over 2. And I put in asymptotes wherever my graph is hitting the x-axis, because I am going to be drawing cosecant, and so I can put in the cosecant curves to correspond to the sine curves.